Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue with our course of marine air condition systems. And this is the chapter 4. Probably the chapter will be divided into sections because it's too long. We are going to talk about the evaporator, we are going to talk about the receiver, the dryer, and also we are going to talk about the different type of expansion valves. Yes, it's a nice chapter. I hope you enjoy this episode. Okay, we are going to start with the evaporator. Yes, the evaporator, this one, this element located here, located inside of your home, in the cabin of your car, in the cabin of your boat, is located inside. Yeah, it's the radiator that is located inside. Because the radiator that is located outside is the condenser, you remember? The condenser that is around the compressor outside. Inside, we have a radiator that is together with the blower. Yes, my friend, this magic element is the evaporator. The evaporator is magic because suction air with ambient temperature from one side, and in the other side you receive cold air. Yes, this is basically because this motor suction the air. Look, the air at the ambient temperature here enter over there. Remember that here is located the filter. No, the filter is located here. It's going up and down. This is the filter that you should replace periodically. Periodically. The majority of the problem with the evaporator is because the people never replace the filter. Okay, the air enter at the ambient temperature over there, and outside here, the air is cold air. Cold air. Yes, that's the secret. That's the evaporator. Okay, but the evaporator produce a lot of problems if the service on the evaporator is not appropriate. For that reason, check the quality of the filter is the first step. And other additional tips that I am going to explain in this episode. Okay, my friend, where is located once again? Yes, it's located inside of the boat. It's located inside in the cabin. It's located in the master room. It's located in the kitchen, inside. Because this element, the other one, the condenser, is located in the bottom, in the engine room. Yeah, in your home, it's located in the backyard. Yeah, that's the condenser. All right, the evaporator and the condenser. Right now, we are going to talk about the evaporator, and we are going to try to understand what happened internally in the evaporator and why in one side enter air with ambient temperature, and in the other side you receive cold air. This is basically because of the refrigerant. You remember the refrigerant in the cycle. This is the magic part of this business. The refrigerant is in one portion of the cycle absorb heat, and in other portion of the cycle release heat. In one portion of the cycle absorb heat in the evaporator or in the condenser. Absorb heat in the evaporator. Yeah, in the evaporator absorb. Oh yes, because absorb heat, the air with ambient temperature let the heat over there and pass through the other side with less heat. Absorb heat in the evaporator. Because absorb heat in the evaporator, here you have a condensation of fresh water, because here you have a fresh water accumulated for condensation. Yeah, yes, in the evaporator the refrigerant absorb heat, and where the refrigerant release heat. Of course, release heat outside, release heat in our boat, release heat in this coil, internally in this coil, and for that reason the salt water coming out here is hot salt water. hot salt water. That salt water that you see coming out through the boat when the air conditioner is running, that salt water, if you touch that water is warm, is hot. Yeah, because internally in this coil, reduce the temperature of the refrigerant. You remember? Because you have two pipes. You have one small pipe with refrigerant surrounded for the big pipe with salt water. Yeah, I explained in the previous episode that situation. Yes, my friend, this is the situation with the evaporator. The evaporator is located inside. The evaporator absorbs heat when the air passes through the coil, and inside of the evaporator, in the bottom of the evaporator receives the refrigerant liquid at low temperature and start to evaporate. In the output of the evaporator, the refrigerant is completely vapor. Superheated vapor. And this is the vapor that enter. And in the compressor. This is the vapor that enter here in the compressor. Superheated. And the compressor compress and produce vapor in the output. Vapor supersaturated. In the output of the compressor here is vapor. And that vapor enter in this element that we are going to talk today, the receiver. And that element have two functions. Start to condensate that vapor into liquid, that's the first function, and the second one, absorb humidity. Once again, my friend, remember, we are going to talk later about that, and we are going to do the process to remove heat. The enemy of the refrigerant is the humidity. The enemy of the refrigerant is moisture. Yes, and we are going to try to remove moisture from the system with the vacuum pump. We are going to do the vacuum process in 3 different type of equipments, in a self-contained unit, marine unit, in a chiller contained unit, a marine unit, and in a training board that we have in the laboratory. In all of those 3 elements, we are going to do the vacuum, and we are going to check the process. It's too simple. I hope that you enjoy those coming episodes. Yes, my friend, this is the typical consideration. We are going to refresh here. The air conditioned evaporator is a heat exchanger that absorbs heat, I explained, into the air conditioned system. Yeah. The evaporator doesn't exactly absorb heat. It's the refrigerant. Yes, I explained. It's the refrigerant. Okay. Because the refrigerant internally through the radiator is at low temperature. It's boiling. But it's at low temperature, because you remember what is the boiling point of the refrigerant? Minus 22 degrees Fahrenheit. At that low temperature, it starts to boil. This is the boiling point. Of course, at the ambient temperature is vapor, 100% sure. But it's too low. The temperature is practically frozen. For you and me, it's frozen. For the refrigerant, it's too hot. Yes, for the refrigerant, in the output of the evaporator, the refrigerant is superheated. Yeah, it's completely vapor. Yeah, but if you touch that pipe in the output of the evaporator, it's too cold. But for the refrigerant, it's too hot. All right, keep in mind that the boiling point of the refrigerant is at minus 22 degrees Fahrenheit. This is a special substance. It's a hydrochloroform. Yeah, we are going to dedicate one episode only to study the different type of refrigerants. Yes, in that episode, that's your homework, we want to take the EPA certification. You need enter in internet, register, and take the EPA certification. This is part of this course, part of this class. Yes, my friends, because in the future, you need buy refrigerant. You need recovered refrigerant. You need disposal refrigerant. And the only way to do that is with the license. And what is the procedure to get the license? Is pass the EPA certification that we are going to take in a couple of episodes. I'm going to explain the procedure, and that's your homework. Take the EPA certification. All right. Okay, my friends. Nice. This is the evaporator. Okay, my friend. The liquid refrigerant, remember that the refrigerant enters in the bottom of the evaporator in a liquid form. The liquid refrigerant usually flows from the bottom of the evaporator coil and boils into the output of the evaporator. The reason it feeds from the bottom is to ensure that the liquid refrigerant boil before leave the evaporator coil, of course. That's the main reason. If the refrigerant was fed from top, the liquid refrigerant drops by gravity into the bottom of the coil before it absorbs and not heat to boil. Yeah. For that reason, should be entering in the bottom to evaporate in a progressive form. If enter on top, drops and no absorb heat. Alright? Okay, if the evaporator was to feed liquid refrigerant into the air conditioner compressor, it short the life of the compressor. Yeah, my friend. I repeat in a previous episode, and I am going to explain later again, that the compressor receives the refrigerant vapor in one side, the high temperature vapor, low pressure, but in the output is vapor supersaturated at high pressure and high temperature. In other words, in the compressor you have vapor and vapor in both sides. Vapor at a low pressure and high temperature, and in the other side is vapor again, but is high pressure and high temperature. All right, vapor and vapor. Oh, this is in the compressor. This is in the compressor. In the expansion valve that we are going to start to study in this episode, in the expansion valve, at the input of the expansion valve, the refrigerant enter liquid, high pressure, high temperature, and in the other side is also liquid, but low pressure and low temperature, practically frozen. Yeah, this is at the expansion valve. In the expansion valve, liquid. In the compressor, vapor. In the evaporator, enter in the bottom liquid and goes in the output vapor. In the coil of the condenser, outside, enter vapor and goes liquid. The opposite. Yes, because it's condenser. Condense the vapor into liquid. And the evaporator evaporate the liquid into vapor. Okay. Yeah, simple. If you understand that cycle, you have cleared the air conditioning system. And we are going to refresh that explanation when we try to add refrigerant into the system. When we added refrigerant, the refrigerant in the gallon normally is vapor. A little amount is in the bottom liquid, but it's vapor. Okay. If it's vapor, I want to add refrigerant in my air conditioning equipment. Where you think that it's good idea introduce the refrigerant? Through the low pressure side or through the high pressure side? Yes, through the low pressure side, because in the low pressure side is vapor, the blue one. And I am going to introduce the refrigerant through the low pressure side. When you buy this bottle to recover the refrigerant in your car, you introduce that feeding in the low pressure feeding of your car, of the air conditioning system in your car. And you start the engine, of course, because you need the compressor running, and the compressor is belt driving, you remember? You start the engine and you put the air conditioner in maximum, and you add it through the low pressure side. Now, we are going to do that process in other episodes later. Okay, my friends, this is important information. Okay, how is the evaporator? How is the construction of the evaporator? And now we are going to analyze the evaporator. We are going to refresh quickly the operation of the evaporator. Remember that the freon pass to the dryer, and after that, if you check, the diameter is reduced dramatically and of course this is the capillary pipe, and the pressure and the temperature is reduced, and the pressure and the temperature enter in the bottom of this evaporator, of this coil, of this serpentine, and of course here is liquid at low pressure and low temperature, and immediately pass through the capillary pipe and enter into the evaporator, start to evaporate. Why? Because this element, the blower suction the air, suction the ambient air of the room, the air pass over there. Here is the filter that you replace periodically. The air pass over there. Remember that those pipes are practically frozen. When the air pass over there, because the fan is working, you have air, you have cold air coming out because the fan is spinning at high speed, and you receive air, cold air, in the output of the blower. This is the operation of the blower, and of course the blower is activated with 120 to 140 volts, and that voltage is coming from the central control box that I am going to explain in the next coming episode. How is the wiring of that central control box? Okay, this is the evaporator. This is simple. Once again, this is the filter that normally you replace in order to protect that those fins be clogged with dirt and debris, because it's supposed that the serpentine over there is practically frozen. This is the evaporator. This is the typical evaporator, cooled by air. This is the evaporator cooled by air. There are other type of evaporators cooled by water. In that case, those evaporators work with a chiller unit. And now, in the next episode, I am going to explain the chiller unit. But this is basically the function of the evaporator. And what is the element that starts the evaporator? The signal is coming from the central unit, the central control box. And the central control box receives the signal from the thermostat. When the thermostat is activated, immediately this element sends the signal and activate the evaporator, the blower, and activate the compressor. And both units start and produce the refrigeration cycle. Yes, this is typically the evaporator. And I have $1 million question. Can I install with one compressor in the bilge of my boat more than one evaporator? Can I connect more than one evaporator with one compressor? The answer is yes, but that amount of evaporators should be calculated. If you are an engineer with the experience to calculate, according with the capacity of the compressor, how many evaporators can I connect, you are authorized. If not, I recommend call an expert, call the dealer specialized in air conditioning system, and they recommend the compressor according with the amount of evaporators that you want to install. Yes, it's possible, but should be calculated. Let me explain why. Let me explain why in particular. This is the typical split unit or remove evaporator. This is the typical split unit. You have here the condenser located in the engine room, and you have the lines. You have the lines to connect air remotely the evaporator. And in the output of the evaporator, you have the ducts, and you have the grill with the fresh air. Yes, my friend. The split unit is a very common unit used in marine applications. Now we are going to talk about the remote coil. The remote coil or the fan and the evaporator. This is the element that is located inside of the boat. The remote fan coils or split systems or remote evaporator are used in millions of boat applications. The evaporator coil is connected to the remote condenser using pipes, normally copper pipes, and those copper pipes are surrounded by foam in order to avoid condensation and in order to keep the temperature of the refrigerant inside of the lines properly. In split units, I am going to explain later in the chapter when we recover the refrigerant, depending on the distance in between the evaporator and the condenser, when you recover the freon, you need to take in consideration that distance, because probably you need added more refrigerant, because in the pipes, 25 feet separated, you have a lot of refrigerant. For that reason, the label on the compressor with the amount of refrigerant for that system probably is not enough, because it's a split unit with a remote evaporator. Okay, my friend. This is a other typical installation about the remote fan coil. We have the compressor on the bills. We have the compressor on the bills, yeah, and we have the evaporator on the cabin. Don't forget, this is the vital element, the filter. This is the element that we are going to replace periodically, and this is the element that we are going to service, and this is the element that we need check frequently. I am going to explain later at the end of this episode. We are going to do a simple troubleshoot for the evaporator, and what are the symptoms when the evaporator is working improperly, and what are the consequences if you don't replace the filter periodically according with the intervals recommended by the manufacturer. Okay, my friends, remember, we are going to check quickly how the evaporator works. At 40 degrees Fahrenheit, this is the temperature at the output of the expansion valve. At 40 degrees Fahrenheit, the refrigerant flows through the evaporator. It absorbs for example, 75 degrees Fahrenheit indoor heat, producing the liquid refrigerant in the evaporator to boils. Yeah, the refrigerant starts to boil because the ambient temperature around the coil in the evaporator is 80 degrees, 75 degrees, 90 degrees Fahrenheit. Of course, immediately the refrigerant internally inside of the evaporator starts to boil, start to pass from liquid into vapor. The temperature of the refrigerant will always try to equalize with the ambient temperature. The 75 degrees heat will flow through the 40 degrees refrigerant and increase the temperature and boil the refrigerant. That's the typical explanation that I did before about that situation. Okay, my friends, and now we are going to check what happened with the humidity. When the moisture condenses on the windows, on the surface of the windows, you have problems. When warm air passes across the fins, the cold fins of the evaporator, of course, the air loses heat. The air loses heat, the refrigerant gain heat, and the air that you receive in your face is cold air. That's clear? The warm air passes through the coil. The coil is practically frozen. The refrigerant is at low temperature. When the warm air passes through those coils, what happened with the refrigerant? The refrigerant absorbs heat. What happened with the air? The air loses heat, and you receive fresh air. Bingo. And what happened around the pipes of that coil? Water is condensated, and that water goes into the water pump, and that water should be drained. That water should be drained. Yes, my friend, this is the condensated water. The condensated water is over there, is accumulated here, and that water tries to go out. Okay, what is the recommendation with those pipes with the condensated water. The moisture is collected at the bottom of the evaporator, of course, in a condensated pan, and is removed by piping into the central drain or outside to the boat. Yeah, in some cases the people drain that water outside of the boat. The condensated drain line should never be connected to the raw water discharge line. Okay, my friend, be careful with this because this is very, very important. Be careful with this picture. Here we have condensated fresh water. This is fresh water. And what happened here in the other side? What happened in this point? In this point we have salt water. We have salt water. All right? That salt water is going warm, a little hot. This is the salt water used to cool the refrigerant in the condenser. All right. And this is fresh water. Never mix it, this drained fresh water with the drained salt water. Never, never, never. Never try to put both of them together in one pipe. Okay? Those drains should be separated. The drain of fresh water separated from the drain of salt water. Don't forget, in the output of the condenser, the water that is coming out is salt water. That salt water is coming from the a.c.r, pass through the strainer, raw water pump, pass through the coil and goes out. Alright? This is salt water. This is salt water. And what happened in the evaporator? In the evaporator is condensated fresh water. That fresh water condensated in the pan is drained here. And for that reason, it's good idea install the P-trap. Why? Right now we are going to check. The condensated drain must be oriented so that they can route it continuously downhill. Yeah, for gravity. It is acceptable to install a P-trap in this line to contain a small amount of water in order to prevent migration of carbon monoxide into the cabin. Yes, because what happens if in this particular case, this outlet is pretty close to the outlet of the generator, to the exhaust pipe of the generator or the exhaust pipe of the main engines. What happens with those vapors, those gases? If you don't have the P-trap, if this line is completely straight, if this line is completely straight like this with no P-trap, enter gases in the cabin. And what happens if you are sleeping with the carbon monoxide entering into the cabin? Finito. Bye-bye. Alright? Be careful with that. This is very, very important. For that reason, the P-trap is highly, highly recommended. Okay, my friend. Important. Don't forget the service on the evaporator. This is a very, very, very important. We are going to check quickly the typical consequence when the evaporator is working improperly or is damaged. Okay, what is the enemy of the operation of the evaporator? The enemy of the operation of the evaporator is that the people never replace the filter according with the intervals recommended by the manufacturer. Remember that the filter is located here. The filter is located over there. Okay, at the input of the evaporator. Okay, if you don't replace that filter and the filter is clogged, and remember the coil of the evaporator, the pipes are practically frozen. What happens if the filter is clogged and less air than the recommended pass through the coils? What happened with those pipes? What happened with the ice around those pipes? Increase, and suddenly you have that situation. It's a block of ice. Why? For two reasons. Because the air filter was clogged. Three reasons really. One is because the air filter was clogged. The second one is because no filter and the air passing through the coils is with the dirt, with debris, and clogged the fins on the coil. For number 3, because here in this picture, the motor, the fan located here internally, the motor, because here we have a fan, is spinning too slow or is damaged. It's not spinning. The motor is not running. The fan is not working. One reason is because the air filter is clogged. Other one, no filter, and air with dirt, with debris, clogged the radiator. And number 3, because the blower, the motor, is damaged. Be careful with this. The number 3 is very important. The majority of the evaporators, they have a capacitor on the motor, on the electric motor of the blower. Yes, that capacitor, you remember in previous episode, help to start the motor. Yeah, you remember when I explained in electricity induction motors, the capacitors is used in single phase motors to help to improve the starting procedure of those motors. Yes, it's used to help to start the motor. What happens if the start capacitor in induction motors is damaged? Probably the motor starts too slow, and continue slow, because the motor needs the jump from the capacitor. Yes, one possibility is that the motor in the blower is spinning too slow because the capacitor is damaged. If the motor is spinning too slow, you have problems with the motor, probably with the capacitor. How can I check the capacitors? Check my video how to check capacitor. It's too simple. You remove the capacitor, you disconnect the capacitor, and you check the capacitor. In that moment, when you have the cables of the motor free, because you remove the capacitor, this is the moment that where you can use the megometer, and you can use that video how to use the megometer to check the condition of the winding of the motor of the blower. Yes, you can check the capacitor, and with the measure you check the condition of the winding of the motor. Okay, what is the symptom when you have a problems, for example, with the blower or problems with the air filter? What is the first symptom in the cabin of your boat? Oh, behind your bed, a lot of water. In your home, oh, you have in the saloon a lot of water. In the kitchen, water. When you open the cabinet and you remove the filter, you found that this, a block of ice. Yeah? There are other possibilities with the refrigerant, low level of refrigerant, moisture on the refrigerant. Yes. How can I know if the refrigerant, the level of refrigerant is low? This is another common problem. How can I know easily that in my air conditioning equipment, doesn't matter if it's in my car or in my home or in my boat, what is the symptom when the level of refrigerant is low? It's because the compressor start and stop frequently. The cycling of the compressor is frequent. Start and stop. You know your home, and you know that in your home during the summer, the compressor works 12 minutes and is off for 18-20 minutes, and once again start and you know. What happens if suddenly you hear that the compressor each 3 minutes start and work 5 minutes and stop and start again and stop? Too quick. This is the typical symptom that the level of refrigerant is too low. Yeah, cycling in the compressor. Okay, how can I verify that the level of the refrigerant is low? In my air conditioning equipment, I have a dipstick to check the level. No, because this is hermetic. you never check the level of refrigerant. You can check the pressure on the system. Yes, my friend, you need this. You need to check the pressure of the system. In this particular case, you have the gauge. You have the gauge for high pressure connected with the high pressure side of the compressor, and the gauge with the low pressure connected with the low pressure side of the compressor. And with the gauge, we are going to use the gauge later in the next coming episode. You know how much is the pressure in the low pressure side and how much is the pressure in the high pressure side. How I know what is the pressure recommended? Depends on the refrigerant. For that reason, if you check in internet charts like this, they have the recommended pressure for the low pressure gauge and high pressure gauge for R134A, or for 410, or for R22. In that chart, you found the pressure for low pressure and high pressure at operational temperature of the system. Yeah. How I know what type of refrigerant is used in my equipment? Normally, in the label located on the evaporator or on the condenser, in the label they say the type of refrigerant and the amount of refrigerant. This is important. When you recover the refrigerant, you need to put exactly the same amount. Okay, my friends? Yes, the secret is the set of gauge to check the pressures. Okay, if the pressure is too low in both sides, probably I need added more refrigerant. Yeah, and we are going to check later in other episodes dedicated only to troubleshooting that situation. But yes, right now we understand the evaporator. We know that if we found that water inside of our home or in our car or in our boat in the cabin, accumulated water in the bottom, and we open the closet and we found that a lot of water, we have problems with the evaporator. Check immediately the filter. Oh, I have ice. Okay, that's the problem. The coil of the evaporator is clogged, and what is the next step? Okay, you need wait until the ice become completely liquid. Can I help with a heat gun? Yeah. And after that, I recommend clean with a special product for evaporator coils. That one, or bleach is good. And after that, with the water at high pressure, you clean the evaporator, and with air at high pressure, you blow the air in order to clean the fins of the evaporator. That's the only way. I recommend do that process once per year. Normally in my home, during the winter, I clean the evaporator with bleach, water at high pressure, and the blower after that. Yeah, and I eliminate all the debris and particles in between the fins of the evaporator. This is the typical way to check if the evaporator is working in good conditions.